Okay, let's go over a few of these. I don't think 1 and 2 got to worry about that, do you? Let's go down to, I think the Isosceles Trapezoid, that was pretty easy too. Let's go down to like 7 through 10. See those? That was on the quiz, but let's go through it one more time. Well, let's take a look at what it says. All right, it says the measure of the interior angles of a regular polygon is given. So it says it's a regular polygon, which means what? All the what? All the sides are equal, and what else? All the angles are equal. So that's very important. When you see that phrase, a regular polygon, it means all the sides are equal and all the angles are equal. It says find the number of sides in this polygon. So let's say you had 900 degrees. It says the measure of the interior angles. Let's just write that down. Oops, let's change that to a little bit thicker. Okay, so it says the measure of the interior angles of, it's a lot of words, and I know a lot of you guys just kind of skim over this stuff, but you got to see what these words say and what they mean. The measure of the interior angles of a regular polygon is, and then in this case it's what, 900. We'll just do the first one. So 900 degrees. The question says find the number of sides. So find the number of sides in that polygon. Okay, I showed you a way to do this. There's a couple ways you can look at this. I think this is definitely the easiest way to look at it. Now, you don't know how many sides there are. Remember we did this? We just kind of did like a blow-up version of this. Remember that? We didn't draw the sides because I don't know how many sides to draw, do I? Because that's what the question is. That's what I'm trying to figure out. So I don't know how many sides I can draw, but I do know that the measure of the interior angles is, actually, let me think about this. So a regular polygon is 900 degrees. So I'm not going to be able to do, this is not like the one on the quiz, is it? All right, so we will have to go through the formula. Yep. Well, I don't know. I just hate to say, okay, do this, do that. I want to see where you get this stuff from. So let's talk about this. The interior angles, okay? The measure of the sum of the interior angles of a regular polygon. So how do you find the interior angles of a regular polygon? It's n minus 2, right, times what? 180. Would you agree with that? That gives you what all the angles add up to be. Now, if it's a regular polygon, I could figure out how many degrees, or how would I find out? Let me think what I'm trying to do here. Measure the interior angles of a polygon. Okay, is 900 degrees. Yeah, so that's equal to 900 degrees, correct? Yeah. And to tell you the truth, yeah, let's do that. Does that work? Hold on. Okay, let's go back to this. So what is this right here? This is the sum. This is a formula for the sum of all the angles, right, of a polygon. And this tells you how many degrees the sum of all the angles actually is. So what am I going to have to do? What do I have to solve for? Number of sides, right? So if I just solve for n, if I set up my formula right here, and I don't want to just say, okay, this is what you do. You divide by 80 and add a 2, because people are like, well, why do you do that? Well, this is why you do it, because you've got a formula, right? So you use the formula. n minus 2 times 180, that tells you the sum of all the angles, and that equals 900. So now what you want to do is you want to solve for n. Now the fact that this is a regular polygon really doesn't make any difference. They didn't even need to say this was a regular polygon, right? Because the measure of the interior angles of any polygon is this formula right here. You follow me? Now, if they asked you for each angle inside of the polygon, then you would have to know that it was a regular polygon. But they don't ask you that question, do they? They just say, what are the number of sides? That's all they ask. So let's do this. How would I solve for n? Well, it's being multiplied by 180. So how can I get rid of that 180 if it's being multiplied? I divide by 180. And then I come over here and I divide this by 180. All right, so that cancels. And so now what am I going to have? I'm going to have n minus 2 equals whatever that is. So put that in your calculator and you get a 5. One more step and you're done, right? Just add a 2 to both sides. And what is n? N is 7. So there's 7 sides. All right, so if all the angles add up to 900 degrees, that means there's 7 sides. If you wanted to just check to see. What do? You put it back in, right? 7 minus 2 is 5 times 180 is 900. So that does work. Okay? What if you wanted to find, they don't ask you this on this question, but what if they wanted you to find each angle? What is each angle inside this regular polygon? Well, if all the angles are 900 degrees, there's 7 sides, so there's 7 what? Angles. So what do? Lonnie, you said it. Divide it by 7, that's right. And that can tell you what each angle inside of a 7-sided polygon, regular polygon, is equal to. All right, so whatever that is, what is it? 9, let's turn it on, 900 divided by 7, and it's a weird degree. Okay, it doesn't come out exactly even, but it's about 128.5 or 0.6, we could say. All right, so it's approximately 128.6 degrees. They don't all come out nice and perfect, but okay. Does that make any sense? All right. So that's how many sides there are if they asked. If they asked to find each angle, you would take the total number of degrees, divide by how many angles you have, and that's what each angle would be in a 7-sided figure. Okay, regular polygon. We good with that? All right. Now, of course, 8, 9, and 10 are exactly the same, right? Right, it's just you divide by 80 and add a 2. But I don't want to just sit here and say, okay, this is how you do it. You divide by 80 and you add by 2. I want you to see why you do it. And that's why you do it, because of that formula right there. Got it? Okay. Let's see what else is on there. Tell you what, let's work our way up to that. 11 shouldn't have been bad, right? What do you do with that? Yeah, right, the diagonals on a parallelogram bisect each other, right? So you just set them equal to each other, solve for x. That's no big deal. What about 12? Let's do 12. Now, this is one that we've done before. We've done all these kind of before. Exactly. All right, so it kind of looks like this, looks like this. It's pretty good right there. So what is this starting to look like here? A kite. And there's a few things you know about a kite. So it's a good time to review some of this stuff. They tell you that this little bit is 3. Tell you this little bit is 4, and they ask for GF, which is this part right there. I'll just put, without all the letters in there, I'll just do it like this. Is that all right? So this is 3, this is 4. So how in the world do I find x? I've done this, I think, twice before, right? What do we know about the diagonals of this kite? What do? They form a what? A right angle. Okay, they form a right angle, don't they? So on a kite, yeah, and they tell you the thing is a kite. Okay, right at the top, they say this thing right here is a kite. So you know that it has to be a right angle. So look what we have. Everybody see this? So here's the triangle we're looking at, this one that's shaded in. This side is 3, this side is 4. This is the hypotenuse. Why is it the hypotenuse? How do I know that's the hypotenuse? Yeah, it's not because it's the longest side, it's because it's what? Opposite the right angle. Okay, because I don't know what the longest side is, right? Because I don't know what that side is. But I do know it's opposite the right angle. Now, the hypotenuse will always be the right side, or the longest side, but it's not the hypotenuse because it's the longest side. It's because it's opposite the right angle. All right, anyway, let's do this. What can we do? Pythagorean Theorem, right? So 3 squared plus what? 4 squared equals the hypotenuse squared, right? The hypotenuse always has to go out there by itself. We can do this. That's 9. That's 16. That's 25. That equals x squared, but that's not my answer. It's not 25, is it? I got to take the square root. And what's the square root of 25? It's 5. So x equals 5. We'll just put it right there. Actually, we're going to do I've told you this before, we're going to do a chapter in a couple chapters, I think it's chapter 8, where we talk about right triangles. This side is 3, this side is 4, this side is 5. It's actually a special right triangle that we're going to talk about. It's called a 3, 4, 5 triangle. So actually, after you recognize that, did you really have to go through all this stuff after you recognize 3, 4, 5? No, you don't. Okay, so if one leg is 3 and the other leg is 4, the hypotenuse will always be 5. Okay? For instance, what if you had something like this? What if, now this doesn't exactly be on the test, but what if this was 3 and the hypotenuse was 5? How would you figure out what this is? Well, it's a 3 blank 5 triangle, right triangle. So what is that blank? It's a 4. So that's kind of nice right? Instead of having to go through all the math, you can just look at it and notice it's 3, 4, 5. All right, we'll talk about that when we get to chapter 8, but I just thought I'd throw that out there. All right, it is nifty. Let's do 13. We've done this in the last day or two, but I just want to make sure that we are clear on this. So it looks like that's that. This comes like that. It's pretty close. Might not be perfect, but it's good enough for us. This is 67 degrees, and this is 49 degrees. It says that this side is equal to this side, and this one is equal to this. So that means it's a right, or it's not a right, it's a what? It's a kite. All right? So what do we have to do? They ask you to solve for angle D, which is this angle up here. So let's solve for that angle up here. Done this a couple times already, right, in the last day or two. So what in the world do we do? Is this equal to one of these angles right here? No. What is this angle at the top equal to? The angle down here. That's right. So these two are equal to each other, right? These two are not equal to each other. Everybody see that? How do I know these are the ones that are actually equal? Well, because it's between the two non-equal sides, okay? So the angle between the two non-equal sides are actually equal to each other. The angles between the two equal sides, see it? They're the ones that are not equal to each other, right? So what do we do? Do we just take this away from 180, or what do we do? That's right. Add these two together, and then we're going to take it away from 360, because all four of those is 360, right? So let's add up 67 and 49. That's a 6, and that's an 11. That's 116. But that's not my answer, though, is it? No. I take 180 minus 116, and that's what? That's a 4. Yeah, what am I doing? 180. See? See, I'll even mess up. I got to think a little bit. It's 360 minus 116. Thanks for that. And that's a 5, and that's a 4, and that's a 4, and that's a 2. Does that mean this angle right here is 244? No, it means this angle plus this angle is 244. They're both exactly the same, so what can I do with this 244? Divide it by 2. So if I divide it by 2, I'm splitting those two in half, right? So that's what? 122. And that's what this angle is right there. That's 122. And of course, that's what that angle right there is. It's 122. All right? It's like the third time we've done a problem exactly like this. So make sure you know how to do those. All right? Let's move on. Let's talk about a rhombus, like 14, 15, and 16. Let's just draw one. Actually, I'll tell you what, I've got one already drawn up here. Let's... Okay, and let's scooch back down to where we were. There we go. And they got a few diagonals in here, right? If you guys are paying attention, those with their heads down, missing some valuable information here. But apparently, you don't care. I've seen, especially on that last quiz, I've seen some direct relationship. There's a math term for you. A direct relationship with those that have had their heads down recently and their grades on the quizzes. All right? So, so with maybe an exception or two, but I have seen that happen. So, I mean, it just, to me, it's pretty obvious. Keep your head up, pay attention. You're going to have a better chance of doing well in here. M, N, what's that? O, P, R. Okay, it says find angle MRN. Let's find MRN. Start at M, go to R, go to N. This is a rhombus. It told you at the beginning that this thing was a rhombus. So what's true about the diagonals of a rhombus? Just like the diagonals of a kite, what do? They make a 90-degree angle. Exactly right. Okay, you got to know that. You have to know that. And that's the answer. It says find an angle MRN. It's a right angle, so it's 90 degrees. Easy. Okay? It says a PR is 12. Find RN. Oh my goodness, this is way too easy. I got to make these problems harder, don't I? So if this is 12 right here, what is RN? RN? Come on, you're playing around. It's got to be 12, okay? Because why? What's the reason? Because the diagonals do what to each other in a... they bisect each other, okay? So they bisect each other. So this is 12, this is 12, all right? Then it says if angle PON is 124. Let's find PON. Some of you guys are having a hard time finding which angles they're describing.
Is it always the one that when they have it's the one in the middle?
Yeah, absolutely. Look, you go from P to O to N. So what angle is that? It's this whole big angle right there, isn't it? That's angle PON. And it says that angle is 124 degrees. I don't know. What? And it says find angle POM. The question says, and we'll do this in a different color, find POM. That would be just this right here. All right? Well, what do we know about the diagonals of a rhombus? They do. On a rhombus, they bisect the opposite angles, okay? They don't do that on a regular parallelogram, okay? But they do it on a rhombus. What is a rhombus? A rhombus has all four sides equal to each other, okay? So they do bisect each other. So if this whole big angle right here is 124, what's this little blue angle right here? It's half of this, which is 62 degrees, all right? Okay? They're making this really easy. These are just real basic type problems, okay? Now, they might do something like this. They might say that this is like 6x minus 3 or something. You got to find, I don't know. They may not do that, but you know what I'm saying, right? There is a lot of problems where they'll do that kind of stuff. They'll put x's in there. They made these really, really easy. They could be a lot of the x stuff as well. Let's, I think we're fine. 18, 19, and 20, that's like too easy. Let's go to 21, 2, and 3. That's a little bit tougher. And I heard a lot of people moaning on some of these answers, meaning that you didn't get them right. So this might be good. Oops. Let me change to the, forgot to change to the straight line tool. There we go. And there we go. Alright, and let's put some letters in here that they do. D and G and E and F. Alright, and we're good to go. And it says this is a rectangle, so if that's a rectangle, that has to be a right angle. Agreed? All of those corner angles are right angles. So here's what they tell you. They tell you, let's do a different color here. I'm on 21. So it says if DF is equal to this. Now look, they write this kind of crazy. X minus plus 5 minus 7. Alright, look at that stuff. That's what DF is equal to. This whole thing from here to here is this thing. And it also says EG because they want to test your algebra skills, alright? No, are you kidding me? How much? You've probably done more algebra in this class than you did in algebra class.
Yeah, this is
okay, we've done a lot of algebra in here. So it's not like there's algebra, then there's geometry, and the two don't mix. I mean, they absolutely mix, alright? Question says find EG. So this is what we're finding. We're finding EG. Yeah, absolutely. So let's see the relationship, though. This is DF, right, which is this diagonal right here. Are we listening? So they tell us DF is this thing right here, and they tell you EG is this right here. Well, what's true? This is a rectangle. What's true about the diagonals of a rectangle? They equal each other. They're exactly the same. Is that true about every single parallelogram? No. Is it even true about a rhombus? No, it's only true when it's a rectangle. It's also true about a square because a square is also a rectangle, okay? All right. So these two are equal to each other. Doesn't make sense? Right. Because a square is a four-sided figure with all four right angles and all four equal sides. Because a rectangle doesn't have all equal sides. Square is a rectangle. Because a square, what does a square have? All right angles. What does a rectangle have? All right angles. So a square is a rectangle. Okay? But a square also has all equal sides. Does every rectangle have equal sides? No. Okay? There's actually, on the worksheet I'm going to give you today, there's a chunk of questions like that. They ask you, is every square a rectangle, or is every parallelogram a square, and you know, that kind of stuff. And you have to think a little bit about that kind of thing. All right, so let's do this, though. DF and EG, what's true about them? They're equal to each other, right? So guess what we're going to do with this and this? We're going to set them equal to each other, all right? So, and we've done this all year long. But this one's a little bit more complicated. This tests your algebra skill a little bit more than what we've been used to. But that's always good for us. So what we're going to do, right, So first thing we're going to do is distribute the 2. So that is 2x plus 10. But then we got to put a minus 7 here. Let's distribute the 3. So that's 3x minus 6. That's easy. Let's simplify the left-hand side before we start moving stuff around. 10 minus 7 is 3. It's a positive 3. Equals, and then you can't really do anything to that. Now you can get x on the same side, can't you? Yeah, I would do that. I would subtract a 2x, wouldn't you? Yeah, because I'd rather not have a negative 1x. So we got the x over here on the right-hand side. Let's take this number, this minus 6, and move it to the left-hand side. We did the opposite sign. Some of you guys, listen, I noticed on the quiz, some of you guys, you're setting stuff up right, but you're doing your algebra wrong. I saw people do this, like a plus 3, and then they add a 3 to both sides. Can you add a 3 to get rid of a positive 3? You got to do the opposite, okay? So some of you guys are just making little mistakes like that. You got to be careful with that. All right, that cancels. So what do we get here? That's a 9, and that's a what? 1x, or just x. So x equals 9. Is that my answer, though? No, because the question says find EG. So what do I have to do? Plug that 9, right, in for what EG is. So this is EG. If you wanted to distribute out and make it 3x minus 6, you could have, right? Let's just put the 9 in here. It's 3 times what? 9 minus 2. It's 3 times 7, and that is 21. So EG is 21. And DF's got to be the same thing, too, if they ask for that, right? That's all there is to it. So really, that wasn't that difficult. It was just the algebra. All this stuff was a little bit more complicated than we've been used to. But you know distributive property. You know how to do all that stuff. That shouldn't be that big of a deal. But practice it. You never know what it's going to look like on the test. I get these like telemarketers calling me all the time, and I even blocked that number yesterday, and it still didn't. Nah, it's a machine. What you can do. So what I did is I Googled the number. All you do is put the number into Google, and sometimes it'll tell you where it's coming from. And if it's somebody that's not prank calling, but what did I say, like telemarketers and stuff, there's like a forum on there, and it'll say, yeah, did anybody get a call from this number? And then a bunch of people write in, yeah, I got a call from this number. I answered it, and it's just a machine. Or yeah, this number's calling me 3 or 4 times a day, and then and all that kind of stuff. So it's kind of interesting to see that other people are going through the same thing. It is kind of a pain. But anyway, let's do
What do they call for?
sell stuff. Yeah. I wonder if anybody actually buys stuff when they call. You know what I mean? Because everybody I know always hangs up on them and stuff like that. Yeah, it's like, oh, thanks a lot for calling me. Yeah, I think I will buy that thing that I have no need for. Yeah. Right, yeah, hang it up. We don't even answer our home phone anymore because of that. Because the way I look at it, if I don't know the number coming in, I'm not talking to them. They can leave a message. And yeah, that's when they call, because that's when they know people are home.
And they're like, all
right, here we go. Let's look at number 22. This is number 22. Let's go a different color. It says angle EDF. Let's take a look at this. EDF. Where is EDF? Here's E, right? Here's D, and here's F. So which angle is it? It's just this little skinny one right there. That's EDF. And it says that angle right there is 5x minus 3. All right, and then DFG. Find DFG. Here's D, here's F, and here's G. So it's this angle right there. And that angle, I don't have enough room, I'll write it right here, it's 3x plus 7. Question says find angle EDF. So we're actually asked to find that angle right there. Well, what's the relationship between here? Yeah, lucky guess, right? I mean, almost all the time. Not all. A lot of times, I should say, they are equal to each other. But let's figure out why they're equal to each other. Because this is parallel to this, since it's a rectangle, right? This is a transversal. And so what is this angle to this angle? There's a special name for it. They're alternate interior angles. Good. We've talked about that quite a bit, haven't we? All right, so they're alternate interior angles, and alternate interior angles are equal. So we just set these equal to each other. All right, set them equal to each other and solve for x. Let's do this very quickly. So subtract a 3x from this, and I get 2x. Would you agree? That goes add a 3 to this, and I get 10. Divide by 2, and I get 5. Is that my answer? Do I just solve for x? Please read the question, okay? Read the question. The question says find this angle right here. It says find angle EDF. Right? Yeah, absolutely. People do all the time. We'll solve for x and just leave it like it. Leave it as x. Read the question. The question says find the angle. So what do we do with that x equals 5? Plug it in, right? 5 times 5 minus 3. That's 25 minus 3 is 22. So that's 22 degrees, that angle right there. Okay. If they wanted to, they could ask for this angle right here, couldn't they? How would I find that angle?
Minus it from 90.
Minus it from 90, that's right, because this is a right angle, isn't it? So 90 minus 22, which is 68 degrees. Okay? So they could ask you for stuff like that. You got to read the problem, though, okay? You've got to read what they ask for. And that's pretty much it. You can do 23, but that's just as easy. They tell you D, E, and G, F. Watch. They tell you the top one, and they tell you the bottom one, and they give it in terms of x like this. So you do the same exact thing. You set this equal to this, solve for x, plug it back in, and you're good to go. You can do that one. You can do that one yourself. You got that one wrong?
Sure, I'm freezing.
Let's just do the math on that one, okay? So you set them equal to each other. So it's 14 plus 2x. Now you're going to hang on to this because this is review for the test. I'll collect it the day of the test. Okay, here we go. So let's do the math real quick. We did one earlier. Let's do it again. What do we do here? Distribute. 4x minus what? 12. All right. Now this didn't really change, did it? But what's this going to be? It's going to be 4x minus 6, right? Subtract a 2x from both sides. You guys watching? Add a 6 to both sides. So that cancels and that cancels. That's 20. And that's 2x. Divide by 2, x is 10. But the question says find the length of the side. So you take x is 10, you stick it in either one of these. This is the easiest one, right? So put it in for here. 2 times 10 is 20, plus 14 is 34. Okay. Don't know. Check your math. All right, I'm going to give you a worksheet. The worksheet is due on Monday. We're going to go over that, and I'll collect this and the worksheet the day of the test, which is what day? Tuesday. So test chapter 6 on Tuesday. All right?